Hi everyone, good morning. So I'm Adrian Vincent MU, a level 1 student of Ateneo de Zamboanga University, and I'm a nursing student, first year student. And I made this video because I want to share ideas, techniques on how we can have the data for the statistics problem that we want. So in this video there are two statistics problems that I need to solve. There are two scenarios, so I apologize for if I will commit mistake, if there are data that are not accurate, or if it is wrong. I want to apologize because it is only my first time, but I assure you that I really try my best to have the correct data for the two statistics problem in these two scenarios that I have. So first, I will now read the first scenario. This is the first thing that I will do. So I will read this before I will start. Level of education and income. This is the first problem. Data for these two demographic variables were collected by the U.S. Bureau of Census in 1970 and summarized by zip codes. Years education. This is the average years of education for adults 25 years or older. We need to find this data. The second thing we need to find data is household income, average household income. For your information, out of the approximately 32,000 zip codes in the US, we have data for a sample of only 500. This particular sample is not random, but similar results to the ones we shall see here would be obtained from using a random sample of residential zip codes. As we work with this data, remember that we are not dealing with characteristics of individual people, but with summarized for zip codes. A zip codes may contain individuals with a wide variety of incomes and educational backgrounds. One suspect at least hopes that there is a positive association between education and income. Positive association means that an increase in one variable is associated with increase in the other. One common way to measure the degree is association in the coefficient of correlation, often denoted by R. So therefore, procedure: first, find the correlation between income and education for the 500 zip codes in the sample. Second, based on this information, find the equation of a regression line that expresses income as a function of education. The third procedure, create a scatter plot with the line of best fit. Fourth, predict the household income. And fifth, comment on the results that I will have in this problem. So the first thing I will do is find the correlation. I will start with number 1. Find the correlation between income and education for the 500 zip codes in the sample. So income and education for the 500 zip codes in the sample. Second, based on this information, find the great equation or regression line that will expresses income as a function of education. Third, create a scatter plot with a line of best fit. Fourth, predict the household income. And fifth, comment on the result. So I will start with finding the correlation between income and education for the 500 zip codes in the sample. Screen. Start. First, in calculating a correlation coefficient. In terms of calculation, first we will begin with calculating the mean of x and the mean of y. X is the household income and y is the years of education. So let's begin. The X is the educational income, and the Y is the use of education. So write the mean of X and Y first. Starting with X, we are just going to add all of these values together. All of values of X from the top until it goes here in the line of 502 is the last data. We will add all data from the top until here to the bottom. Also, we will do this into the Y data, the use of education. We will also do the same procedure. So, these are the sum. 12,001. So this is the sum, 12,168,005, and for the Y data, which is the use of education, is only 6,034.7, and we will divide it by 500 because 500 is the zip codes. So divide it to 500, this is the result, 24,936.41 We now add the mean for the X. This is 24,936.41, for the mean of years of education, 12.07. Then the second, next the second step for finding the correlation. So next, we need to calculate deviation score for each variables. So I will explain about deviation score. How we can get it, we need to subtract the mean. This is the mean for the X, and this is the mean for the Y. Okay, mean for the X, mean for the Y. We need to subtract the mean from each value. They are called deviation score because they indicate how far each value deviated or departs from the means. So the next step for the deviation score, I will explain how I got these scores. So as you can see, I did this. The next step will be all X and Y data will be subtracted to the mean of X and also all X and Y. The mean of X is 24,936.41, while the mean of Y is 12.07. So example of calculation, X data. This is an X data. You will subtract it to the mean. If you subtract it to the mean of the X, this data, and this will be the deviation score. Also, this Y data, which is 12, and you will subtract it to the mean of Y, which is 12.07. It will be the deviation score. You do it continuously until you reach the last column, which is 500, do the same procedure. I will repeat. The procedure is the X data and subtract to the mean, which is 24,136.41, and we will do it also into the Y data, subtract it to the 12.07, which is the mean, so you will get the deviation score. Now we're done. These are the deviation scores, as you can see. Step 3, we need to square each of the deviation scores because it gets rid of the negative number. So to get the square of each deviation score, add the deviation score both. We will do this both into the X and into the Y. I will explain it in a while. So here's the example. This third column, letter D, deviation score. If you to find the square root, you should multiply this by itself and this will be the square root. Sorry. So repeat it again. I will explain it here. So to find the square of each deviation score, you should multiply it by itself. So this is the square root. When you multiply this 1,881.59 by itself, this will be the result. Square root for the X, and for the Y, to get the square root of Y, we should do the same procedure. Find the deviation score. This is the deviation score, example 0.93 times by itself, and it will be the 0.8649. This will be the data that we will find the square root. We will do this continuously into the last data. You see, I did it until 500. These are the square root data that I got when I multiply the deviation score by itself, both X and Y data, both into the X and also into the Y data. So next, we need to add up the squared values. These are the squared values. Technically speaking, we call this the sum of the squared deviation score. So result, when I add all the squared values of X, this third column until into the 500 zip codes, this will be the value 33,502,135,832.95. And also if I add the Y value, we also add the square deviation score into the Y column, and result is result is 7 0.06. So we're done. We're now ready to the next step. Finally, we need to find what are called cross product. Cross product just multiply the two deviation score together. Multiply all the deviation score together. Deviation score of x times 12. This will be the result. When you multiply x times 12, this will be the result. And now, we'll find the sum of the deviation score when you multiply the deviation score of x into the deviation score of y. So this is the result. So the result is this is the result. The sum 304,694,304,694,8,315. So this data is ready for the final step. So this is the 3,046,948.31. So for the final procedure, we will now find the R value. Sixth and final step, divide the cross product, which is 3,046,948.31 divided by the sum of squared values of x, which is this, the squared value of x, 33,502,135,832.95, and the squared values of y is 754.06. So first, multiply this squared value of x, the sum of squared value of x and y. After you multiply it, what will be the answer? You will divide it by the y 3,046,948.31, and our correlation data is ready, and the answer is R equals to 68580.343. So we're done with that procedure. So now, based on this information, find the equation of regression line that expresses income as function of education. So I already find this for the regression line. This is my regression line. This is W1 is the years of household income, and this orange one is the years of education. So the solution is slope 0.00, y-intercept 9.80. So the linear equation for this is y equals to 0.00 times x plus 9.80. So this is the final linear equation. The y is years of y is the years of education 0.00, and x is the household income, which is 9.80. This is our data for the linear equation. So now we are ready to show our scatter plot with the line of best fit. This is our data, household income, and years of education. So, now we're ready to predict procedure. I'm not sure which screen, so I can demonstrate how to I make this number 30 just to make an example so I can predict the income. This serves as year 2013 only made as an example. Predicted income is, so before I can get it, I will use my solution, which is first equals, then parentheses, type the word forecast, then open parentheses, highlight the year 2013, comma, then now highlight all the X data, which is the income. Then which number? So now highlight, again, comma, then highlight all the remaining datas. Will put those parentheses 2 times and enter. So as you see, this is the predicted income, 28,696.70. So now I'll share my experience with this statistics problem. So comment is both the X. This is part of your procedure. The comment. My comment is both the X and Y data has a strong relationship with each other. Based on the regression line, so as years increases, income increases also. Also, the predicted income is a positive number, so it is a strong relationship between the X and Y. So that's all for the first problem.